Hello class, here we have lesson 3, the shifted form of a parabola, and in this lesson, really the objective of this lesson would be to determine the vertex, otherwise known as the turning point, of a parabola. Okay. And to be able to do it without necessarily typing your calculator, but at the end of the day you can type it in the calculator, but sometimes the parabolas don't fit, find in the window, and if you've done any playing around, sometimes it's hard to find certain turning points with the table. Sometimes you have to scroll up and down quite a bit. So what I'm going to do in the first exercise here is talk about something that came from, I think, lesson 2, and it talked about how to determine if something opens up or opens down by looking at the number in front. So without using the calculator, we're going to sketch each of these parabolas on my own set of axes. Okay? So if I think about the standard form here, so I'm just going to sketch a XY grid. Okay? And these special equations, if you remember them from the previous lesson, they start at 0. This is going to start at 0. Right? And this one, because it's a 2 and it's a positive, this is going to open up. So that, remember that from the last lesson, the number in front of the x squared, or the leading coefficient, is the vertex. Yeah, I'm sorry. I got distracted by hearing my TV in the background. But it determines whether it opens up or opens down. And then we'll look specifically more at what that number 2 does. What it actually does is that it determines how wide or narrow the parabola actually is. All right, now when I look at B, and I start to graph this, what I'm going to notice is that because it's a negative, this means it's going to open down. And this standard equation, this y equals x squared, we call it the standard equation, okay? Always the vertex is at the origin. So in this case, the vertex would be at the origin, and because it's negative, it's sloping down, and because it's a negative 3, it's going to be fairly narrow. And obviously, I'm not looking for anything to be exact. Okay? So, here's some general forms of parabolas that you've got to be able to recognize. So, if you have a parabola in the form y equals ax squared, and there's nothing else, then the turning point is always at the origin 0, 0. All right? So, now we're going to move on to exercise number 2, and in this exercise, we're going to take the basic quadratic function, f of x equals x squared, and a more complex quadratic function, which is this, right? And the graph of f of x equals x squared is already shown here. Okay? So, what I'm going to do is, we're going to first graph this function, sketch it, make a table, and sketch the graph. So, if I go into turn it on, y equals, I have this, I was playing around with one of the problems that's actually on the assignment for this lesson, but alright, so I'm going to put in parentheses. Thing about using these calculators, and I've always said, is if there's parentheses, you have to put them there. So this would be x minus 2, close parentheses, square it, and then I'm going to do the minus 4. Okay? And I'm going to go ahead and go, well, I mean, you're going to want to see what the graph looks like. So here's the graph. Okay? But we're going to go ahead and do the table. Okay, the one thing about recognizing where it is this pattern. This 5 matches 5, 0 matches 0, negative 3 matches negative 3, negative 4. This happens in every parabola. Okay, it's not always visible in the table, but it is something that does always happen. So I'm going to go ahead and plot these points. Move this over here. Can't really see it. I can still see it, but all right, so I'm going to do negative 1, 5. Negative 1, 1, 2, 3, 4, 5. 0, 0. 1, negative 3. 2, negative 4. And then here is the pattern that repeats. Okay. Now, that's not my best work in sketching that, but that's what we end up with. Okay? So what happens is, and they call this a shifted form, is that the parabola is still got, if you look at the width here, this is 2, this is 2. You know, you pick 2 more points here, this point and that point is 4. You know, these 2 points are 4 apart. So it didn't get any wider or any more narrow, but what happened is it actually moved. Okay? So if I looked at the vertex, here's the vertex at 0, 0, and now this vertex has a vertex at 2, negative 4. And what that means is that this graph has been shifted. Now, in 8th grade math, we talk a lot about transformations and how things are translated. It's actually called translation. And it's something that you guys didn't get last year, but it's relatively straightforward. It was shifted to the right 2 units and down 4 units. Okay? So the turning point is now 2, negative 4. And if you look carefully here at this 2, negative 4, and you look back at the function, you see the 2 and the 4 in this problem, in this form. Okay? Now, the negative 4 matches the negative 4. But what you notice is that that negative 2 is kind of, I'll use the word counterintuitive, meaning that it does the opposite of what you think it's going to do. Like you would think negative 2 means go left 2. But because this is in parentheses and the squared is there, that changes this to something a little bit different. So this negative 2 really means it's going to be shifted to the right 2. Okay? And we're going to look at some more so you get the idea of that. But it's going to be something that's going to be hard to get over. The negative 4 matches, but the negative 2 becomes a positive 2. All right? And there is a pretty, I had to actually look it up because it's been a few years since I've done this, and I couldn't quite remember exactly why this happens. The negative 2 really becomes a positive 2. And it does have to do with the fact that the 0 there, if you put a 0 there, you get a negative 2, and when you square it, it becomes a positive. Okay, so that's basically, it just changes the sign on it anyways. But moving on, let's take a look. Okay. This lesson might take me a little bit longer to get through because I want to make sure I'm doing a good job explaining it and I'm not rushing through it. Because you guys know that when I rush through things, I tend to make mistakes. So, the parabola y equals x squared is again on the graph, and consider the two functions y equals x squared plus 2 and y equals x squared minus 4. Okay? Now, what I'm going to do is I'm going to put these in. So I'm going to do x squared plus 2, and I'm going to do x squared minus 4 in my calculator. And I'm going to actually just go right to the graph so you see what happens. So see how you got one above, and then there's one below. Okay? So what really happens in this is that this x squared plus 2 means that it's going to shift up 2 units. And this minus 4 at the end means it's going to go down 4 units. All right? Okay. So here we go. I'll just get these on the graph real quick and, go to the table. You can pause the video if you need to get to the table, but right. So, but I'm just going to go ahead and this one is up here and this one is down here. Plus, I know graphing is very difficult, especially if you didn't have the yellow book that you brought home with you. And something that, trying to find graph paper to actually use. So, all right, and then what happens? What is the effect of adding a constant to the overall function? By adding a constant at the end, it shifts the function up or down. And if it's positive, if it's a plus at the end, it shifts up. If it's a minus at the end, it shifts down. Now the turning points, here's the interesting piece. This is part of the objective of the lesson, is to be able to look at this equation and determine the turning point. Well, for this one, the turning point was up here, your vertex. So this is just 0, 2. For this one, it's down 4, 0, negative 4. Okay? Based off of this information, what would the coordinates of the turning point of this parabola be? Okay? Well, if this one was 0, 2, and this one was 0, negative 4, this one's going to be 0, negative 150, because this parabola is going to be shifted down 150. All right? Okay. Now, let's see about that number added and subtracted from the input x variable before it is even squared. Yet again, here we got parabola y equals x squared, graph below, and then we got these two considered here. Okay? So what I'm going to do, what I want to do specifically, is the first thing I'm going to do is I'm going to put the first function in. Okay? And so I'm going to have x plus 3, and I'm going to square it. And we're going to look at the graph and see what happens. So here's what the graph looks like. And if you look, here's the original graph. Now you're over here, and if I go to the table, I'll see there's my pattern, 9, 9, 4, 4, 1, 1, 0, 0. And if I started plotting this, this is at negative 3, 0. See, negative 5, 1, 2, 3, 4. So the parabola actually gets shifted to the left. And this is the y equals x plus 3. Okay. Now, at any time, make sure you pause. If you need to pause, to take time to put it in the calculator, or, you know, to actually take a minute, you know, just by all means, whatever you got to do. All right, y equals. Now I'm going to clear this out. Now I'm going to put this one in. So I'm going to parentheses. Remember, you always have to include the parentheses. Otherwise, it's going to... My cat's messing with my dishwasher. All right, let's look at this graph. And what you see is that this one seems to be shifted to the right. And if I look specifically at the table, all right, all right, there's my pattern, my 9s, 4s, 1, 0. So what I end up with is, this ends up over here. So what that essentially means is that this one was shifted right. Okay? And as I said, it's your calculator. Why is the horizontal shift counterintuitive? It's a great question. It has to do with the fact that when this is squared and you put a 0 there, it changes the sign inside. Okay? And I will get a more specific definition for that if you want. But for right now, we know that the x plus 3 shifts to the left 3, and the x minus 1 shifts it to the right 1. Okay? And it has to do with the fact that it's in the parentheses. So now, the coordinates of the turning point would be, state the coordinates of the turning point of each parabola you drew in A. So the coordinates of this turning point was negative 3, 0. Now the 0 comes from the fact that there is no constant term at the end. So neither of these have constant terms at the end. Therefore, this one would be a positive 1, 0. Okay? Now, oops, sorry. Let me move that up so you can see. Okay. And it's not complicated to actually determine what happens in these shifted forms, but it's just remembering that inside the parentheses is opposite of what you think. So here's some examples of basic quadratics, and you see a couple of them. I threw the 5 in there and the negative 2. Now, the value of the number in front, like that 5 is going to be irrelevant and that negative 2 is going to be irrelevant when it comes to the turning points. And it's because that number just determines if it opens up or opens down, and how wide or narrow the parabola is. So in regards to the turning point, you know, it doesn't change anything. I'm sorry, it seems to be moving here somehow. All right, so here we go. Coordinates of the turning point. Turning point are going to be these numbers, okay? But what's going to happen is the 8 is not going to be negative anymore. It's changed the sign, and then 5. So the turning point of this particular graph is going to be 8, 5. This one, the one that's inside the parentheses, gets changed on the sign. So this is negative 1, and the constant term, negative 4. Okay. Like I said, the 5 is irrelevant. Here, the negative 2 is irrelevant. What we look at is we look at the negative 3, which changes to a positive, and a negative 10. Okay. So one thing to remember is that inside parentheses, the sign changes. Outside parentheses, the sign stays the same. All right? So as we look through this will be the end of this, and I might spend more time here as well. Let's see. Trying to anticipate what types of questions that you guys might have about this. I am going to go and give you a better explanation for this But for right now, just know that if it's inside parentheses, the sign changes if not. Okay, and then that means I can even give you a ridiculous function like y equals negative 4.9 x minus 2.7 squared plus 111. Let's say I just gave you that equation. And I said, okay, what's the coordinates of the turning point? Well, the turning point in this case would be, the negative 4.9 doesn't mean anything. It would be 2.7, because I would change that to a positive, and 111. Okay. And if I wanted to take it one step further, I would say that this would be a maximum. Because remember in the last lesson we talked about if it's negative, it's going to open downward. And if it opens downward, it's going to have a high point. Alright, well, this lesson definitely took a lot longer than what I usually intend these lessons to be, but like I said, I wanted to make sure that I was trying to explain myself the best way that I can and take my time. So, the assignment would be to work on the problems on the next 2 pages, and I also will have a lesson checkpoint for you to do, and we'll be looking at a quiz at the end of this, and I will provide review materials, and there will be more information to come on that. So, for now, this is Mr. Sims signing off.